At this stage, we've now created an animation controller which features a blend tree that allows us to blend between different animations for the Ethan character. What I want to do in this movie is to create a C# script file that can access the parameters of the blend tree and drive the animations. So right now you can see in the project panel we have our animation controller. This has been assigned to the controller field of the animator component when I select the Ethan character here in the scene. What I want to do is to now create a completely new script file. So I'm going to come down here to the project panel, right click and choose create, and then choose C# script from the context menu. I'm going to name this script char controller and press enter on the keyboard to create a completely new script file here. And what I will do is I will select the script file and drag and drop it onto the Ethan character here. And when I select Ethan here in the hierarchy panel, you can see that we have a char controller script component attached. I will double click on that script to open it inside MonoDevelop here so that we can see the component here, or the code inside MonoDevelop. And we're now ready to get started at scripting this character. So the first step is to retrieve a reference to the animator component that is attached to the object. To do that, I'll create a new private variable, which will be part of the animator object here, so animator, and I will call that this animator, and it will equal the initial value of null. And inside the awake function, I'm simply going to retrieve a reference to that component. This again includes nothing that we haven't seen before, so I'm going to get component, and the component is going to be of type animator, which means that when the level begins, we get access to that animator. In addition, we're going to be reading input from the keyboard, so I'm going to include a reference to the cross-platform input controller with using Unity standard assets here, and it's going to be cross-platform input manager. So I'm going to accept that there. And inside the update function, I'm going to use the getAccess function of the cross-platform input manager to read input data. To do that, again, we've seen this before. I'm going to choose cross-platform input manager.getAccess, and we're going to be reading data from the horizontal axis here. And I will select that line, copy it, and paste it. And pretty much we're going to be doing exactly the same thing, but for the vertical axis. And this will allow us to read up, down, left, and right data. Now the question is, how does this data map to the animator? Well, we can do this. We can grab the this animator component, and I'm going to move down and press this animator dot, and we have a function set, and we have the choice here of set bool for setting Boolean values, that is values that are true or false. If I scroll down, you can see that we can set, for example, integer values. We can also set triggers, but in this case we're interested in setting the floats, the fractional numbers. So I'm going to choose set float, and there are different versions of this function. If I choose the open parenthesis, in fact you can see that there are 4 versions of this function. We're not going to be using this version, but one very similar to it. So first it expects a string name. So that is the name of the parameter inside the animator that we want to set. So we want to set the horizontal field. So I'm going to grab the horizontal string to paste that name into there. The second parameter is the value itself. So for example, for the horizontal field, I want to set that to the horizontal value that we read from the keyboard. If I press a comma for the third parameter, you can see that we have the fields damp time and delta time. This allows us to smoothly blend between different animation states so that we don't have sharp transitions from one animation to another. For example, if the user is turning left and then very suddenly they turn right, we don't want too sharp a transition. We want to smooth out that transition, and the damp fields and the delta time fields allow us to do that. So I'm going to choose damp time field of 0.1 seconds, and the fourth parameter is simply going to be time.delta time. I'm going to grab that line and copy it, and then I'm going to paste it beneath. And whereas I was setting horizontal for the top line, I'm going to replace that with vertical, like so. If I can spell today, and take the vertical field and paste that into here. I'm going to press Ctrl S on the keyboard to save the code and close MonoDevelop, and then return back to Unity. Again, in the bottom right hand side, you can see the code compiled successfully. So now I'm ready. In fact, I've got some errors there. I'm just going to clear those, and I'm going to go back to the play bar here and choose play. And you can see we have the Ethan character standing here in idle pose. I can press the left keys on the keyboard to turn the character, the right key to make him turn right. I can move him forwards and turn him around, and he responds to my controls entirely here. Now there is one way still that we can optimize our code even further. I'm going to double click here, move to the char anim folder, double click on the char controller script to bring back our script. And there is a way to optimize this by taking a look here at the update function. So here is the update function. And one of the things that we're doing for set float is we're specifying the floating point fields using the horizontal and vertical values, but these are strings. Now ideally we don't want to deal with strings inside an update function. That is simply not ideal or optimal. Instead, it would be better, much better for performance, if instead of dealing with strings, we could deal with integers. And it would be great if there was a way to take a string and to convert it into a unique integer, so we could be sure that no two strings produce the same integer. If we could do that, we could use the integer instead to specify the parameter. And Unity allows us to do exactly this by converting the strings into hashes. And I'm going to show you here how we can do that. So I'm going to create two new variables, private int, and we're going to have a vertical hash. And I'm also going to have one for the horizontal. So let's start with the vertical hash. All I have to do to access the hash here is to grab the animator component and press dot. And we have a static function called string2hash. And inside the argument here, we simply put in the string that we want to convert to a hash. So I'm just going to grab the string vertical, and that will convert vertical into a vertical hash. I'm going to do the same thing, but this time for the horizontal axis. So grab horizontal and change this from vertical hash to horizontal hash. And now we can simply replace these strings down here for the hash values. So I'm going to grab vertical hash, and I will replace that with the vertical one here. And the same for the horizontal. Paste those in, press Ctrl S on the keyboard, close MonoDevelop, go back to Unity, recompile that code, and then when I press play on the toolbar, we get exactly the same behavior as before, except this time our code is working much better. So that's how we can go ahead and create a blend tree complete with different animation states, and then link it to a C# script that we can use to drive a character that moves around the scene and still interacts with physical objects through the character controller.